Hello everybody, my name is Kari-Matti Vuori. I come from Finnish Environment Institute. And the acronym comes from Climate Change Adaptation Tools for Environmental Risk Mitigation of Acid Sulfate Soils. The project has just started and lasts for 3 years. And Finnish Environment Institute is the coordinating beneficiary, and other partners include Geological Survey of Finland, MTT Agri-Food Research Finland, Universities of Åbo Academy and Helsinki, and Finnish Game and Fisheries Research Institute, and South Ostrobothnia Center for Economic Development, Transport and Environment. The total budget of the project is around 2.8 million euros, and the contribution from LifePlus is around 1.2 million euros. And this is the figure on the major problem. The acid sulfate soils, they are kind of geochemical anomalies present in our coastal areas. The upper figure here on the left-hand side represents the Baltic Sea after the Ice Age, some 8,000 to 4,000 years ago. And in the middle up there is a figure on the conditions where the sea was under that period, very shallow and highly productive, and very excessive amounts of sulfur and metals in the sea water, and very rapid and extensive sedimentation took place, and these sulfuric clay sediments were deposited during that period, during the thousands of years. And after that, the land uplift, the natural phenomena of the Ice Age, has resulted in these soils to be usable for agricultural use, and drainage for agriculture is the major use of these soils and sediments nowadays. And when they have been drained, excessive amount of the sulfuric compounds in the mid figure here, they are oxidized, and consequently the metals and sulfur compounds and protons, they are released. And during the drought periods, the oxidation is very effective. And after the drought, there always comes some rain, which is related to climate change issues here. And when the rains come, episodic or long-term release of acidity and metals follow, and these flush into the water bodies, and ecological deterioration of them and impoverishment of the fish stocks follows. And in this map we see the situation of the ecological status of our water bodies in whole Finland, and red and orange colors, they represent the most damaged water bodies, and most of them are situated in this western coastal area where acid sulfate soils affect the water bodies. And this is largely the area where we are working in our project. It's approximately some at least 300,000 hectares of acid sulfate river basin areas present in this area. And we suspect that more will arise if the climate change affects these river basins, as we anticipate that it will be the reality. How climate change affects water bodies, how it affects acid sulfate soils, roughly speaking, there will be increased and more common drought periods and temperature rises, and there will also be increased precipitation and floods in future, especially during autumn-winter period. And this follows as increased release of acidity and metals, and also increased exposure of ecosystems to lethal concentrations of metals. And as a consequent, increased deterioration of water bodies and fish stocks is anticipated if no protective measures are taken. This project has the following objectives and actions. The overall objective, of course, is to promote wide application of certain kind of techniques and actions which reduce acidity and metal concentration concentrations in drainage waters. And the actions planned are to increase knowledge, first of all, on the location, on the quality and quantity of acid sulfate salts in river basins, and also to develop cost-effective tools for mapping the exact location of these hotspot areas, and to collate all the information available on the degree of environmental degradation taking place now and in future, to construct climate change risk scenarios and identify future problem areas which are now not known, and also evaluate how effective are the current pollution measures and what are the constraints to use those measures under changing climate. And we also develop and demonstrate pollution control techniques which are specifically tailored for changing climate conditions, especially the lowered groundwater level conditions during extensive drought periods. And last, we assess the socio-economical impacts and constraints and the feasibility of different adaptation tools available under the changing climate conditions. Well, shortly, quite concrete demonstrations and interaction, a lot of interaction with local people, farmers and stakeholders will take place. We go to the field and establish pilot field areas where we show how controlled drainage systems can be used and how to build such calcium carbonate filters and how to select suitable crop plants and how to change the use of the fields and how these actions affect the river basins and water bodies. Thank you, that's all.